PowerPoint page. So when I may start?
Yep, I guess we can start right away. In this case, let me welcome everybody to this webinar. The last one actually before Plenary 9 and the third one in the series of webinars showing various adoptions of the data citation recommendations. So as I said, we will have the plenary next week, and then we are looking forward to scheduling another webinar on implementations of the data citation solution for long-tail data. That will follow sometime in the second half of April. But today it's my pleasure to welcome Carlo Maria Zwölf from the Paris Observatory, who was actually one of the earliest pilots starting adoption of the data citation recommendations while we were still discussing them and evolving them and contributing intensively to those discussions. It's also one of the most challenging pilots that I've seen so far, I guess, because it's not only for a single data center, but actually for a distributed data infrastructure. And so we're very much looking forward to hearing from you, Carlo, what you have achieved, the issues that you have identified, and how you have actually gone about to implement the solution. With that, I guess I'll just hand over to you, and we're looking forward to your presentation, Carlo.
Okay, thank you. So I just start by recalling what is the Virtual Atomic and Molecular Data Center. It's a federation of approximately 30 heterogeneous databases gathering atomic and molecular data. The V for VAMDC stands for virtual in the sense that the infrastructure does not contain data. It's a wrapping for exposing in a unified way the set of heterogeneous databases. We have a consortium for organizing all the political aspect of this federation. We are proud of the high quality of scientific data coming from the different physical and chemical communities, and we provide data producer with large dissemination platform, so removing the bottleneck between data producer and the wide body of final scientific users. Here I'm going to explain how the infrastructure works, because it is essential for understanding what are the problem we encountered for implementing the recommendation and to understand the proposed solution. So let us consider an independent database. We provide a wrapping layer. It's a set of software which are called VAMDC node. And when a database is wrapped with this layer, it starts accepting queries submitted in standard grammar. For us is a subset of SQL, and in providing output formatted into a standard XML files, which are our own standard, called XAMPP. For further details about all the standard, please follow this link, standard.vamdc.eu. You will find all the documentation about this standard adopted. So we wrap a database, then we wrap two databases, and we have a series of VAMDC nodes, all understanding the same queries and replying to queries, providing files formatted in the same way. All the nodes are registered into registry, so it's a kind of yellow pages. And then we have clients. We have essentially our central portal and science-specific domain tools, for instance, CASIS for spectrum, SPECTCALL for collision, SPECView again for spectra. And when a user submits a query, it's a unique query to the client. The client asks from the registry for all the available nodes, and then the query is dispatched to all the available nodes. The standard outputs are collected in the client and then returned into a unified way to the user. So a user may be a human or another, a workflow step, could be a machine or a script. But it's not so as simple like that, because a user may also submit directly the query to the node without passing by the registry and the client. So our goal was to implement the recommendation in this distributed and not centralized architecture. The RDA recommendation comes from first mainly for standalone databases or warehouse, and the VAMDC is a distributed infrastructure with no central management system. So the first question was how to build a query store in the case of our infrastructure. So the solution belongs to a space with a lot of constraints, because any choice will impact each of the almost 30 databases federated by VAMDC. And on the other hand, any technological change on the infrastructure must be validated from in a political level by the majority of all the members. So this leads us to find a solution that must cause least effect on the existing infrastructure and have a minimal implementing cost for the database owner. So this constraint suggests to fit the solution into the standard wrapping layer, which transform an autonomous database into a VAMDC node. Then we'll discover that the problem was not only technical but also anthropological, because when we look at the recommendation, we have to tag and version data for citing data. So for tagging and versioning data, we see technically how to do that, but the problem is what is the granularity for tagging. Naturally, for atomic and molecular data, there is a context which defines a data set. For instance, if you consider an atomic transition, you have to specify the element and the quantum state of the defining the transition. So this object, this macro object, may be considered a data set. But actually, we realized that each database provider, each database owner, define differently what a dataset is. On the other hand, we think that we are almost agree in saying what is data citation, but we realized that in the RDA context, the idea was more to cite a database record or an output file, in a sense that a file may have an H factor. For VAMDC, it was quite different. For data provider in VAMDC, the idea was that they would like to cite all the papers used for compiling the content of a given output file. So it was not exactly the same definition of data citation. So we decided the solution is the implementation will be an overlay to the standard output layer, thus independent from any specific data node. So it will be the same for everybody, and the data provider do not need to develop anything. And for tagging version of data, we introduced the two-layer mechanism, one which is a fine-grained granularity, which is an evolution of our output file for tracking the modification, and the coarse-grained granularity, and at each data modification to a given data node, the version of the data node changes. So with the second mechanism, we know that something has changed on a given database, and we know that the result of an identical query may be different from one version to another. It's a kind of warning. But the detail of which data changed is accessible only using the first mechanism. And we build the query store over this mechanism for tagging data, and the query store use essentially the coarse-grained granularity. We may say that due to the distributed VAMDC architecture, the query store may be seen as a smart, huge log service. I will explain later this aspect. This slide concerns the fine-grained granularity mechanism for tagging the version of a data. We adopted the change of paradigm, which is a weak structuration. This is more or less the object contained into an output file with elements with energy state, radiative processes, collisional processes. All these objects are interconnected and have relation between one and the other. So the idea was just to introduce a container, which is a version, tagged according to the infrastructure state and update, and then just to put the ID of the other object into this container. So this approach has several advantages because it solves the data tagging granularity problem and is independent from what is considered a data set. So moreover, the new files will be compliant with all the old processing library. And with this new feature, we introduce structuration without changing the schema of the XML file. It's just something which is added without changing deeply the existing. So it's really a good compromise for adopting this this solution. All the technical details are described in a paper which is published in a Journal of Molecular Spectroscopy. There is a free exit version, so I just invite participants to look at this article for all the details about this fine-grained granularity system. And then I will continue on describe this webinar by presenting the query store itself. So again, the difficulty we have to cope with was to handle a query store in the VAMDC distributed environment and to integrate the query store with the existing VAMDC infrastructure. The implementation of the query store is the goal of a joint collaboration between VAMDC and the European project RDA Europe Free. The development started during spring 2016 and the final product release is planned during 2017 during fall 2017. And we have a collaboration ongoing with the editor Elsevier for embedding the VAMDC query store into the pages of displaying the digital version of a paper. So we are actually designing the service for data linking during the process of the paper submission for the authors and the data linking while a reader will download a given paper on the editor platform. So here there is a functional overview of the query store. We have the user, which submit a query to any VAMDC client. The query passes into the VAMDC infrastructure as I shown before. Then a response is computed and the result is displayed. There is a direct access to the output data file, and this is associated with a digital unique identifier which are resolvable, associated to the current extraction. When one resolves this link, the landing page will contain all the query metadata, so the original query, the date and time where the query was processed, the version of the infrastructure when the query was processed, a list of publications needed for answering the query, and when supported by the VAMDC node, the availability to retrieve the output data file as it was computed at the time where the query was firstly submitted. So it is what's called the query execution. From the technical point of view, this is really the core of our solution, and it's more like a ping-pong match. I will show you. We have a client application which submit a query to a VAMDC node. So in this first step, the node generates a query token, which is a composition of the node ID plus a unique identifier, a UUID. This token is more or less a session token. And then the node will answer the query, so it will compute the result file. At the same time, the node will notify to the query store a set of information, the query, the session token, the node version, and the output standard version. So the query store stores the received information in this raw format, then we'll reduce the queries to a standard form. So we have a specific processor we developed for this, which is based on the Anteler library, So we use just a subset of SQL, and our entire library is able to check if the syntax is syntactically and semantically equivalent to another one. It's not a closed problem, it's an open problem. So we are able to say that if our system detects that the query is the same, is identical to a previous one, then we are sure that they are identical. But if the library if the output of this comparison say that the two queries are different, they may be equal. But from our point of view, it's a good solution, because we just know that if they are equal, it's really equal, and then the worst the case, we generate two different UAD for two queries which are semantically the same. So I will start again. We store the information, we reduce the query to a standard form using this library, and we will check if it exists a syntactically identical query submitted to the same node and having the same node version and providing the same exams version file. If the answer is no, we provide the query with a new UUID and a timestamp. We download the output file and we process it for extracting all the metadata, including the bibliographic references, and we store all the relevant metadata. Otherwise, if the query already exists, we incrementally associate the new query timestamp with the already existing query UUID. Then the node return the query token in the header of the response to the client application. There is a second step, which is the association. So the client knows the session token, and he may associate the token with the UUID. So the client sends the query token, the user email, and optionally information about the used client. So the query store, using the session token, will find the corresponding UUID and will make the association. So the output of this association process is the unique identifier, which is returned finally to the client. So the query UID is returned to the user with a link for accessing the UID related to the metadata. So we see that actually the process for submitting a query we saw before, it's a 5-step process, and we put into this 5-step process this 3-step process of the for operating the query store. Then the query store has a set of web services allowing user to browse and discover the stored information into an anonymized form. So we have a set of web services, both human and machine-oriented, for browsing the query and for displaying the metadata associated with a given query. So here we have an example. We provide the query store with the unique with the UUID, and we'll get the output in the machine-oriented version. If I zoom, we see that we have the URL to the data, the timestamp where the query was submitted. We have no query execution link because the node does not support this feature. We have the name of the resource, its version, the version of the output format, and a set of bibliographic references which are which is a BibTeX. Then we have the unique identifier, which is recalled, and we have the parameters which are passed to the system for generating this query. So the authors may cite in an article only the unique identifier. And then we are working, as I said, on a delegation of credits so that editors may use our web service for automatically give credit to all the authors of the paper appearing into the BibTeX. And this mechanism is transparent and easy for the authors, because only a string has to be cited versus dozens of papers which may be used for computing a result file. So the strength of the query store is that the query store usage is transparent for users, all the complexity is hidden, and we have a live monitoring of all the queries and the user on the VAMDC infrastructures. So the data providers are able to measure their impact and have detailed statistics of usage. And also it will be also easy for authors to cite data coming from VAMDC, and the delegation of credit applies. There is a minimal impact for the federated database owner for operating the query store, because the database owner just needs to install the latest version of our wrapping software, and the data providers has only to fill a version field, which is the version associated with the coarse-grained granularity mechanism, and it's simple as string. So there is just a good practice. When the database is modified and or a data node software changes, the version label should evolve. So if we put things together, in the slide where we sketched the solution strategy, we introduced the two mechanisms, the fine-grained one and the coarse-grained one, for tagging the version of data. Here I would like to underline the coordination between these two systems and the query store. So here I sketched the evolution of a database over time. We are a version 1 here. Here we have an alteration, a modification of the data, and the version became version 2. We have the same query which is submitted somewhere at T1 here and T2 here. The same query submitted at T1 and T2 will be associated to two different UUIDs with our mechanism, because between T1 and T2 the version of the base has changed. But these two different UUIDs for the same query is just a warning to the user saying, attention, something has changed. Result may not be the same. But what has really changed? The alteration, for instance, may concern only the helium element, and the query is on hydrogen. So the query result may be unchanged even if the node version and the UUID are different. So the first mechanism, the fine-grained granularity mechanism, track this difference. The evolution of our schema described in our publication is a mechanism for knowing exactly what has changed between version 1 and version 2. So again, the evolution of XAMPP output file is a standard for tracking data modification, and the coarse-grained granularity is just a label for saying that something is changing into a given data node. So finally, we provided the VAMDC infrastructure with an operational query store. The concept adopted and implemented core are quite generic, and both can be adapted to other use cases. The idea is that if it worked in our complex and distributed case, it may work in many contexts, and the cost for adapting an existing service database to a VAMDC type query type query store is minimal, because all the complexity is handled and masked in our generic software. So I just follow this link for the live demonstration. So here is the VAMDC portal. We choose to ask to the system for a given atom, so we choose lithium. Sorry, I just try to improve the quality. Then the request is dispatched, and we have all the results which are displayed. We choose to download a given file. So the file is downloaded, and we have the citation link which appears in the system. We may follow this link, and we have all the data which are displayed, just a graphical user interface presenting the result of the JSON file I showed you before. And here we have the BibTeX code where user may find all the publication of the may find all the bibliographic references. So I've ended with my presentation, and I'm happy to answer to all the eventual questions you have on this presentation.
Thank you very much, Carl Maria. This was great. If you've got any question, it's probably best if you type them into the question window so I can read them out to you, and then I can assign you individual. I hope I can unmute you so that you can ask your question. While we're starting with that, I've got one question, because you showed an example of the response file when a query was sent to a node. What happens if one query goes, as in your live demo now, to a certain number of nodes? Will it then have repeated that, if it goes to 5 nodes, will then there be a list of 5 entries in the query store for each node individually?
Yes, because we consider that the unicity criterion, I will show you back in my presentation. Here, I said that the unique criterion is that submitted to the same node, having the same node version, working with the same output, and having the same query. So it's the recipe for computing the unicity. If you submit the same query to another node, you will have another unique identifier. And if the node is the same and you change the version of the node, you will have a new version. So if you receive answer from 5 nodes, you will have 5 unique identifiers.
5 unique identifiers that you then need to cite as your data set, basically.
Yes.
Okay. Is there a reason why those 5 that are basically are related to one query? It's one query that is sent to 5 nodes. Is the reason why they're not unified?
Was an example. If there are 5 nodes answering, then you will have 5 answers, so 5 unique identifiers.
Okay.
Let me try to show you. So we have our system. It's still in testing, so it may not be working. It's site.vamdc.eu. We can browse all the queries submitted to the system. Here we see that we have the same query here, select star where atom sign bond equal to helium. The same here, but here it is submitted to a base which is called a tip base, and here the base is top base. So if we go to take a look to what is inside, we see that the answer was the request was dispatched from the system. We will see here the data are almost the same, I guess. We have 29 free, 1044 and 1043. We should find almost the same date. Yes, here.
Yeah.
We see that it's the same query which has been dispatched to different nodes, and which is associated to 2 different UIDs, one for top base here and the other for tip base.
Okay.
We see that the bibliographic references are not the same.
Mm-hmm.
And,
But basically, if one asks if one goes to the central VAMDC portal and poses a query to all nodes available, one would still have to cite then each individual node and not one accumulated set that is then dispatched as individual queries.
actually, yes, to cite each file from each node may contain hundreds of publications and different sources. But at this time, at the moment, an author has to cite each file individually.
Okay.
We have UAD to each output.
Mm-hmm.
So, in a smart way, as I presented, if you submit 10 times the same query, you will have 10 times the same UAD if things are not changing.
Mm-hmm. Okay.
But, you will have a unique identifier per node. And we are working to an overlay to that, which is a system for grouping queries, saying that you can create aggregation of queries. Say, here is my publication. I would like to attach to this publication a set of queries.
Mm-hmm.
Then we will have a cluster of queries inside. Then we would like to put DOI on this cluster.
Okay. Mm-hmm.
So people may cite just one publication, this virtual publication, and then our API will be able to go to look at all the generated UAD and to give credit to all the authors and to retrieve all the metadata. So this is the first step.
Mm-hmm.
Then we are actually working in this second layer, which is not really complex. I think we cope with all the complexity now because all the distributed approach is solved. It's working and it's really robust.
Mm-hmm.
And we are now try to, because if we manage a virtual publication, so we have to manage authors.
Mm-hmm.
So we are working for connecting with ORCID system for using their delegation of authorization for people to authenticate.
Mm-hmm.
So basically the idea is that an author with his ORCID identifier will connect to our system, will see all the, more or less like here, we'll see all the query he has submitted,
Mm-hmm.
and he may add this query to a virtual publication,
Mm-hmm.
assign a DOI to this virtual publication, and then just cite the virtual publication.
Cool. That sounds great. Uh-huh. I've got a question by Robert Downs, and I'll see whether I can unmute you. Yes, I can. Robert?
Yes, can you hear me?
Yes, we can.
Yes.
Oh, great, thank you. Yes, you mentioned on the previous slide that you just showed where if a query is the same as a previous query, that it gets a new date timestamp. And what I was wondering is, does the old date timestamp also remain there so that you have a record of the multiple date and timestamps, if you will, so that if people are looking back, if the previous querier looked back, they would also see their date timestamp as well.
Of course, yes. Maybe I can show you here if we follow the link. It was that one. We have all the timestamp where the request was computed. But here we see that it's for version 1. So if we submit the same query, which is the request here, to the system again, if the version has changed, it will be associated to a new unique identifier. So we will reset the counter here or of the request.
I see. Well, thank you.
So you're basically also storing the repeated requests for the same version. Even if it does not change, you keep the timestamp of when they were queried, and as soon as something changes, then it obviously gets a new ID and starts with a new list of timestamps.
Exactly.
Huh.
That's great.
That's great, yeah. So you can even keep track of how many times it was re-requested, basically, the same set.
I can show you the schema. Just verify you don't see my password. So we are here, the query store. How can here is the schema of the database behind the query store.
Yes.
It is a SQL actually, but we don't use. We just use it as flat tables, and we handle manually all the foreign keys, because we say that if we have really lot of data and SQL become too slow or is not adapted for all the amount of data, we will be able to switch with no problem to NoSQL solution like Cassandra database, for example. So this, all the DAO layer is ready for working with Cassandra DB, for example. And so you see that we have the query with all the data, the UID, the accessed resource, its version, the format, the data URL, the set of the parameters, the references, and here we have the link to all the individual requests. So we have the timestamp, we keep the original query, the user email, the user client, the IP, and the query token. So in case of problem, we are able to trace what's happened to the system. We have also a table of errors. For instance, if we have problem during the processing of a query, it may happen if the node produce an output which is not which is malformed, which is not a valid XML file. We have error during the parsing. So for instance, I can show you our example. So here we have the UID associated with the request which was in error, the token, the session token, the detail of the message. It was an XSL default because the file was not well formed. The parameter which produced the error, the timestamp, the phase of our internal pipeline of when all the problem happened. So we can show it. It was during the phase of getting the reference for the file that the XSL failed. So we have a really a compact and general version of all the infrastructure in a centralized way. We made it for implementing the RDA recommendation. Actually, it was really useful for tracking the quality and the issue in our system in a way we didn't have before.
That's great.
Fantastic. One question, do you also have some way of verifying if the answers provided by a node on re-executing the query is correct?
Actually, not all the nodes support query execution. There are very few nodes which support this, and I would like to say that usually people do not like to it's really a huge cost for them. They have further version of the database, and they just keep the old version in flat files. So we are working on try to convince them to migrate to a version solution. And a second order solution we found is that in this system we keep all the query, the data, because since we download the data for extracting metadata, we keep this downloaded data for 2 months. And the idea is to use the overlay I described before for clustering the queries. Say you will be able to cluster only queries which has data. So the only queries which are less older than 2 months. When you assign a DOI to the cluster, we freeze the deletion of the data. So this is an intermediate solution for having data for a long time without forcing everybody to implement query execution. So we will metadata eternally, hopefully eternally, and data only for published work.
Okay.
Yeah.
Do you know whether any of the nodes is actually interested in implementing also the versioning solution on the node side?
Bascol is implementing the versioning. We are working with Bascol, which is a node in Paris, and I with the Bascol maintainers for applying versioning. So we completely we're working on a completely new version by introducing this aspect in the development.
Brilliant. Would be very interested in hearing more about the way of implementing it. So when there is any progress, please let us know. That sounds great.
So just the example on the interface, when you ask for a UAD which is has an error during the processing, so they say we are sorry, there was a problem with this request. We give the message, the UAD, and the request which generated the error. So if you submit a query and you have a UAD, then when you try to resolve it, you find that there is an error, you will be able to contact us for trying to understand what happened.
That's fantastic. And
so if we go to, for instance, to queries, we have all the information here. I don't know how to put this. We have the unique identifier, the resources version, the data URL for retrieving data, the canonical parameter query, re-execution link, there is nothing for the moment, and all the bibliographic reference, the BibTeX. And here we have all the detail about the user which asked the query, so we have the token with the UAD related. And again, the idea is that the software is really generic. We try to implement something which may be easily ported to other use case. It works like a log service. So the idea is if it's worked for us, maybe you can use this mechanism for you for obtaining a query store in an inexpensive way.
How are you planning to share this? So what would be the adaptations necessary, you think?
But actually, we are still in the test phase, and we are just we are in the validation of the program. It's on a closed repository, but at the end, I think we can publish it on GitHub. And we will be happy to help people from other user community try to adapt our solution to their own case. Another thing, sorry, I forgot to show you, is that we implement security, because we may define a set of limited nodes which are able to communicate with the query store. So not all the machine on the internet will be able to communicate with the query store, but just a number of chosen IP may be filtered for saying that these machines are the authorized for interacting with the query store or the submission tool. I don't know if I'm clear. Not to use the query store, these web pages will be available for everybody. But the idea is that the nodes, the machine which are able to submit the information and the metadata to the query store will be only a set of authorized machines.
Yeah, obviously, because only those are actually processing the queries and avoiding that any spurious node inserts queries into your query store. Oh, well designed, very well designed. Congratulations.
Thank you very much. It was not easy to find this solution. It takes a lot of time and reflection.
I can imagine, because starting with a distributed setting when everybody else is just starting to figure out how to do it for a single centralized setting is was quite a brave endeavor. But I'm happy to see that you succeeded.
Sorry, you?
I'm very happy to see that you succeeded in spite of the complex setting that you embarked on. Very well done.
Yes, it's very impressive.
Are there any further questions? If not, I think I will close the recording. Thank you again, Carla Maria, for your presentation. This was really very impressive. And
Thank you for the opportunity.
And I hope I'll be able to share the recording, and we can share the slides that you prepared via the working group website. So thank you very much, and I hope to see all of you in Barcelona next week. Are you coming?
I will be there.
Proud as well. Anyway,
I'll be there.
Yep. Great. So we'll have another opportunity to discuss the next step. So thank you very much again.
Great. Thank you.
Have a nice weekend, and see you next week in Barcelona.
See you next week. Bye.
Bye now.